Good day, grade 12 learners. Welcome to today's technical maths lesson. My name is Moses Maudu. This lesson is brought to you by Gauteng Department of Education in collaboration with Saibono Discovery Center and broadcast by Pagama Research and Development. Please engage us also on WhatsApp. Our WhatsApp number is 079 578. In place of x, I'm going to replace the x by x plus h. Then I replace the x by x plus h. Then we multiply out this and that. You got 2x plus 2h, which is what we are having here. Then from there you subtract the f of x, which is 2x. And then the answer that you got was 2 over h. And then you got f of that. Please keep this in mind because we're going to try to look at it when we're using the rules there. Okay. Now, the annotations that are used in differentiation. So you'll have seen in your classes where they use these symbols. Now, the symbols instructing us to do the differentiation will be d over d. So, or we have that d. So, the capital letter D. The other symbol that we're going to use, if I differentiate to indicate a variable of x, I'll have d over dx or capital letter D with a small x there. So these are the notations that you must know. With respect to the y, so you must first read the question because sometimes they say with respect to x, with respect to pi, with respect to a, with respect to b. So you must read the question and first understand what is it that you're deriving? So we have d over dy or the d with a y there. Okay. The next ones that we're going to be using here is differentiation of f of x with respect to x. So in other words, my f of x will be with respect to x. So I must have an x there. So now I'm going to have d over dx of f of x, d of f of x over dx, or that capital letter D with f of x in there, or f prime x. So we have that little apostrophe there. So f prime, we call it f prime x. So now, the next one there is the differentiation with respect to y. So it will be the same thing, but you remember your y will be there because I'm differentiating y. Or I can write it as dy over dx. Or I can write d, capital letter D with a y. Or I can write y with that little apostrophe there. So it means that I'm differentiating. Okay, so these are the notations that are going to be used. So in an exam or in that, you must check which notation have been used and how you're going to apply that notation in there. I hope we are fine with that. Now, here are some of the rules that we're going to be using. Those ones were the notation. Remember the first one there. Still remember the first one that I've done at the beginning to say we're going to take the n and multiply it with a 1. Remember there's a coefficient of 1 here. So we're going to multiply the n with a 1. And from the n we take away 1. Okay. The second one there is the sum and the difference. If I've got a plus sign, I'm adding something. If I can just make an example, if I've got 3x squared and I have plus 5x, then from there there's that one and that one, so I can separate the two. So I can find the differentiation of that, then get the differentiation of that, and then from there I can be able to write down the answer. Right, then number 3, it's when if I have, for instance, 2x squared. You see, if I've got 2x squared, I am able to, then, so you can see that 2 there will be your k in this case, and I can have my f of x, so I can differentiate those two. So I can differentiate, but the constant will stay the same. Okay, I must not differentiate that constant, please. So I'm going to differentiate. I'm going to multiply this one by that, then subtract the 2. Please don't split the 2, and then from there, then we have the differentiation of that. You can see there it is not differentiated. The k remains where it is. The 2 must remain there. It must just be multiplied by the exponent there. The last one is differentiation of a constant, where k is constant. So when you differentiate a constant, then the answer there becomes 0. So constant will be talking to the pi, will also be talking to a 2, will be talking to a 3. So we're talking to a constant. Even if it's a negative, it's still a constant. So in other words, we must first check deriving with respect to whatever variable that we have. Then we differentiate that accordingly. Okay, but if I say differentiate with respect to pi, it means that your pi, we're going to differentiate your pi. All right. Now let's look at some of the activities. I hope you all remember the ones that we started with, and that one we used it in first principle. We used the first principle. Now let's see. Now what is this thing called calculate the derivative with respect to that? I'm just going to make an example. If I've got y equals to 2x plus 3. Now, what is the gradient of this line? It's a straight line. What will be the gradient of that line? Remember, we have y equals to mx plus c. Then the gradient there is that number that is next to this x. So meaning that that gradient there will be 2 in this case. So the gradient of that will be 2. If, for instance, I don't have that 3 there. I don't have the 3. So it means that my gradient of this line is going to be equals to 2. I talked gradient. So when I talk gradient, now let's look at this. If I differentiate that 2x, see it's the same there. If I differentiate that 2x by using the rules, so I'm going to have f at x, it's equals to 2x to the power of 1. So I know if it's not written there, it's power of 1. Now, how do I differentiate? Remember the first rule that we used? We take the 1, we multiply it with a 2, I'm going to get a 2. Then from there, what do? From the 1 there, I'm going to subtract the 1, so I'll get x to the power of 0. After getting the power of 0, x to the power of 0 is 1. So I'll have 2 into 1, and my answer will be 2. Now, because I've already differentiated, then I put that sign there, because I differentiated on that one. Okay, so now, there I'm going to put my sign there. I'm going to put my sign here, because I've differentiated. Now, if we look at that thing here, and look at this thing there, what do you see? Same numbers. Okay, so what can we conclude? That the word derivative is nothing else but its gradient. So in other words, what are we doing here? We are calculating the gradient. When we say derive, we're calculating the gradient. So the gradient of this line here was 2. The gradient of that line there is 2. So I can immediately write this one, m is equals to 2, and that will be my gradient. So the gradient of that line is 2, and we know that the gradient of that line is 2, so it means derivative means gradient. So what we are doing here, we're just calculating gradient. Okay, so now, the next question here is use the rules of differentiation. You'll see in a question, they'll say, it's either they're going to say calculate f prime x, or calculate dy over dx, or calculate d of x. So if they don't write that, they'll say use the rules of differentiation to calculate the derivative with respect to the x. So here I'm having f at x, it's equals to x to the power of half. So if it's f of x equals to x to the power of half, what do I use? I use my rules here again. So what should I do? I'm first going to write it f at x, it's x to the power of half. I want to derive now. What is the rule for deriving? The half here must be multiplied with a 1 with the coefficient of x. So in this case, because I've already differentiating, I'll write half of x. What do I do with the half there as an exponent? I'm going to subtract a 1 from that half. Okay, I know you love fractions, so let's quickly do that. So the answer there is going to be half of x to the power minus 1 over 2. So we're going to have that one as our final answer. Okay, sometimes you will be requested to write this one as a positive exponent, with your exponent. If I've got x to the power minus n, I can write this one as 1 over x to the power of n. So know your exponents when you're doing this section. Go back, practice your exponents because you'll need them here. So I can either write it as 1 over 2 x to the power of half. But I know that x to the power half can be sometimes written as a square root. So I can put that as a square root. So there's so many ways on how you can write that, depending on what the examiner wants. So if the examiner, but I want you to practice it now. Let's practice it now. We're going to have 1 over 2 square root of x. So we can write this question like that. Sometimes you can find it like this. Please do not forget to write that, because you have already differentiated. We have already differentiated. We're just playing around with that answer there. Okay. So if they say use the rules of differentiation to calculate the derivative, you must know what are you doing? You are only getting the gradient. So if I'm given something like this and I need the gradient of the thing there, so the gradient will be that. But you'll see when we say gradient at a point. So at a point means that we need to find where is the gradient when x is given as, when the x value is given. Please don't forget to send us messages, WhatsApp messages on 079 578 2908. 079 578 2908. Okay, right. We are doing very well. Okay, now the next one. Differentiate the following with respect to x using the rules of differentiation. You see, we're still doing the same thing. We're differentiating using the rules. Your y value is given. So in other words, there's no way that I'm going to write this one as f of x, f prime x. There's no way I'm going to write it as d of x. Okay? So I cannot write them in that way. Ne? Why? It is because now it is written as y is equals to. So I want you to please do this one, and let's see how you're going to do it. And also need there, you must also take a picture of that and send it on your WhatsApp, 079 578 2908. I want you to do this question quickly, and I'm giving you only 2 minutes from now. All right, welcome back. Now we're differentiating the following with respect to x, and I'm still waiting for the answers, but let's see for those who have done it, and let's see if you have done it correctly. I hope and trust that no one wrote these two, because those ones are not, you will not be writing the correct thing there. So now let's see. You have y equals to 3x squared minus 6. So remember that if I've got y written there, so it's either I'm going to write this notation, which means that I'm differentiating, or I'm going to write this notation to show that I'm differentiating with respect to x. So once I've done that, then I must differentiate. I cannot write that one and then write 3x squared minus 6. That will be totally incorrect. Now, I know you love your differentiation. You want to differentiate until you can't differentiate anymore. Please don't do that. So let's see. With this one, 2 times 3 will give us a 6. We subtract a 1 there, so I'm going to have a 1. But what about the differentiation of a constant? So remember, the differentiation of a constant is 0. So now my answer is going to be the differentiation of y equals to 6x. Please stop. Do not differentiate again and then get a 6 and differentiate again and get 0, because I know you enjoy this differentiation, then you keep on differentiating. Please, when you differentiate once, then you stop. That is your derivative. The dy over the x, same principle. Once you write dy over the x, it means that you are differentiating, and then from there your answer is 6x. So I've differentiated that part. So that question was very, very, very easy. I should have given you only 10 seconds to do that question. But I know some of you are still trying to figure out, oh, what is the differentiation of a constant? Oh, you go back to your notes. You must know it's 0. All right. Now let's look at this one. Let's do this one together before I give you another activity. Now differentiate the following with respect to x using the rules of differentiation. So I'm still getting you, making you understand when it's written in ways like that, in a sentence like that, so that you are able to understand why are we saying we are differentiating with respect to that. So it means that the x is there, the y will be the subject of the formula. Because I'm differentiating with respect to x, the y must be on its own, the x values on their own also. Now, how do I differentiate that? So first of all, this is what you are not supposed to do. And I know once I say this is not what you are supposed to do, you do that. But please don't do it. So here we're saying, do not differentiate in parts. And from there, in the same sum, you find that the other part is not differentiated. We've seen where you differentiate this part here, you differentiate this part there, then you change this one, you take it up, and you write x to the power minus 2. And there you write differentiation. That is incorrect. So in other words, I must first write it properly and then differentiate everything. So how do I then write it properly? I'm going to write y. I'm still going to write y because it's still y. So, but the 3 will still be there. The 2x is still there. Now I know I cannot differentiate when I have that fraction like that with an x squared there. So you remember in exponents, what do you do? If I've got 4 over x squared, I can write this one as 4x to the power minus 2. Remember, when I take it up, the sign of the exponent changes. Not the sign, not that sign here. The sign of the exponent changes. So now it means that that is going to be 4 to the power that. You see, I've not yet differentiated, so I'm still writing it properly. Now, then I can differentiate. So I prefer dy over dx, it's equals to, now I'm differentiating. You see, I did not differentiate 3, I did not differentiate 2x before I write that one properly. Okay, so now let's differentiate. The differentiation of a constant, it's 0. the differentiation of 2x, we've already done that. It's 2. The differentiation of this one, pay attention now. So it's minus 2x, minus 2 multiplied by negative 4. So you must multiply it with the negative. So the answer there will be plus 8x. Then I subtract 1 from there, then I'm going to get minus 3. Okay, so let me clean up this thing here. So I'm going to have negative 2 plus 8 over x cubed. I'm now writing it as a positive exponent. But if you're not told to write it as a positive exponent, it's fine, you'll get your full marks. But now let's learn to write it as a positive exponent, so that the examiners, when they ask you to write it as a positive exponent, you already know. Okay, so that is our differentiation of dy over dx, and then I'll get full marks on that one. Okay, right. Now, before I give you an activity to do, let me explain something on exponents again. Right. Calculate f prime x. You see now we have changed. They no longer say with respect to x. They say calculate f prime x using the rules of differentiation. So you must use the rules of differentiation. Now, the f of x is given like that. Now we've got something there. Square root of x. Can I differentiate the square root? What do? Remember my exponents? If I've got 1 over x to the power of n, I can write it as x to the power of minus n. Know that rule. Now another rule, if I've got the nth of the a of m, how can I write that one also? How do I write it? It will be a to the power of m over n. So if I've got a square root, remember a square root, there's a 2 here that we don't write. I'm just going to write it now, but please don't write it. And we have a 1, so how do I write this? X to the power of. The 1 should be the numerator, and the 2 there for the root must be the denominator. Oh, I've already given you the answer. Now, because I've given you the answer, then I'm going to let you do this one for only 1 minute, exactly 1 minute. 1 minute is what we have. Okay, thank you, Lenas. Now this one says calculate f prime x using the rules of differentiation, if I'm given that. So for you to do that, so it means that before I differentiate, I must first write it properly. Because in that way, I cannot differentiate when I have a denominator. So now, what am I going to have here? I'm going to have 3 over x to the power of half. Still, I cannot differentiate here because I still need to take the x to the power half to the top. So I'm going to have, remember I'm still having f of x, not yet differentiated. So therefore I'm going to have 3x to the power of, remember if I've got an exponent like that, I must take this one up and change the sign of the exponent. So I'm going to have 3x to the power of negative half. Now I can differentiate. Once I put that sign, it means that now I'm busy differentiating. Okay, so it will be minus half multiplied by 3, which is going to be, so if I take a minus half and I multiply it by a 3. So the answer there is going to be minus 3 over 2. I have an x. So what do I do with that x? So the exponent is minus a half. So I'm going to say a minus a half minus 1. So every time I subtract 1 on top there, so I'm going to have minus 3 over 2 x to the power of a negative half minus a 1. So it's going to give us minus 3 over 2. I can leave my answer like that, or if I want to show off with my answers, I'll have minus 3 over 2 x to the power 3 over 2. So I'm going to have that exponent as a positive value, so it means that I must take it down to the denominator, then it becomes a positive exponent. So down there, denominator, I see there's a 2, so you must multiply it with a 2. So then I'm going to have that. All right. Okay. Doing very well. So now, let's look at this. This we're going to do it together. We're going to say, now, look at this question now. It says, remember the last question was, calculate f prime x. Then this next question says, the last but one question says, determine the following with respect to, differentiate the following with respect to x. This one says, calculate f prime x using the rules of differentiation. This one says, determine dy over dx. Can you see how they can ask this question? So you must get used to the way on how they ask these questions. Determine dy over dx. So you have a y value, the one that is on top there, the y value there, it means that it is that subject of the formula. Then the dx is what is having there, what you are having there. Okay, so now any other thing here, if it's not x, any other thing, it will be a constant. So if, for instance, they said plus a c, then that c will be the constant. Or plus d or plus pi, that will be a constant. Okay, now let's look at what we're going to do. First of all, remember, I must first write it properly, everything nicely, no denominators, no x as a denominator, and no square roots, no cube roots, no fifth roots. We need to write it properly here. First, before I differentiate, I must write it properly. What must I do? The x cubed must go up there. What does it do? Change the sign. So I'm going to have 2x exponent minus 3. You see? And then I'm going to have plus square root changes to x to the power of half. Okay. So now, then I can start differentiating. So how do I then differentiate? I'll say dy over dx. Please do not differentiate whilst you're busy rearranging your right hand side. Now I can then differentiate. Know you love differentiation. Minus 3 times 2 will give us negative 6x. Subtract a 1 there, I'm going to have negative 4. So then from there I'm going to have plus. Before you put your sign, you must first multiply this one by the coefficient with its sign. This one is easy because down now we have a plus sign, so it's not a problem. Then I'm going to have a half x to the power of. If I subtract a 1 here, I'm left with minus 1 over 2. Easy. So difference these rules, and these rules, the marks there range from 5 to 8 marks on the rules only. So please make sure that you understand those rules. Okay, you understand the exponent is the biggest part also of this part of work. So You need to understand your exponents, and you need to understand those rules in exponent. So as I say, you can leave your answer like that, but it looks very messy. So if I want to show off again, I want to show off. So I'm going to say minus x without the teacher asking me. I'm going to show off. So I'm going to have minus 6 over x to the power of 4. You see now this is over 1. So I'm taking it down, I'm changing the sign. Taking it up, change the sign. Okay, so now here I'm also going to do the same. I'm going to say 1 over 2 exponent of positive 1. 1 over 2. So if I don't want to write x to the power 1 over 2, I can take it back to the root. I can say that's square root of 2. Okay, so that's how we differentiate. But please read the question. The question might say differentiate or determine dy over dx. You can stop here. Okay. So now if they say write your answers as positive exponent or positive exponent, then please write your answers as a positive exponent. Great. Now, the next activity is a bit of a challenge. We're also going to do this one together. Now I can see they say determine the y over the x. But you see my y is mixed with the x there, and I need to make some plane there. Okay? So I need to make a plane. So what plane am I going to be doing there? So here I'll have, remember I'm differentiating dy. So dy must be on its own. And I'm differentiating the x. The x's will be on their own there. So let's do this. So I'll have minus 2y. It's equals to, so what do? I take the 3x and transpose it to that side. So I'm going to have a negative 3x. The square root of x is still like that, so I'm going to put it like that. Then what must I do here? I must make y the subject of the formula. Before I can do anything, before I can derive, I must make y the subject of the formula, because I'm differentiating with respect to y, dy over dx, with respect to x, sorry. Now I'm going to have y, it's equals to negative divided by negative, it's positive. We have an x here. Then negative times positive, it's negative. The square root of x, must I change it? Yes, so I'm going to have x to the power negative, x to the power 1 over 2. Then that is divided by 2. I haven't yet differentiated, remember? I'm still trying to arrange it nicely so. So now I can make a derivative dy over dx. Then I'm going to have, this is a 1. So it's 1 multiplied by 3 over 2. It's 3 over 2. I'm going to subtract 1 there, I'm going to get to the power of 0. Now here, and this is a challenge, because sometimes we're really afraid of fractions, and fractions are lovely numbers to work with. Sometimes we're afraid of fractions, and from there we see something like that, there's a fraction, there's another fraction in there, no problem. Because what you're doing here, you're saying, remember, this is 1 over 2. It's still a fraction. So what am I doing? I'm actually multiplying. I'm going to write it separately there. So if I've got x to the power of half all over 2 is the same as having 1 over 2 x to the power of half. It's the same thing, because there's a 1 in there. So it's 1 over 2 x to the power of half, or I can write it like that. I think in this order it looks nicer. Okay, so now I'm saying, what is half multiplied by a half? So the answer that I'm going to get there will be 1 over 4. And x, we're subtracting a 1 there, so we're going to have minus 1 over 2. But we know that x to the power 0 is 1. So I'm going to have 3 over 2 minus, if I want to write it properly again here, I'll write 1 on top, the 4x, I can write a square root, because that will be x to the power of half, remember, which is the same as the square root of x. No harm if you leave it like that, but without that, please, without that. So no harm in leaving like that, leave it like that, and then you still get full marks on that. Especially when it is written. It is not written that write it in, write your answer with positive integers or positive exponents. Positive exponents, yes. Right. This one now. What do we do with the dx? So here, I'm going to let you do this. Let's see how you can do this one. But before you do this one, I want to say if I've got d of x here, so in other words, first of all, I must work that part out. Remember, I cannot differentiate when I have x as a denominator. Make a plan there. Once I've done that, then when I differentiate, I no longer write this thing. The answer I just write equals to. After I've differentiated, I must write equals to. And then I no longer write that d of x. Okay. Now let's see if we can be able to do that. That I think it can take you around 3 minutes. I think 3 minutes will do. Please, let's do that one. Let's see who will do it first. And send your answers to 079 578 2908. 3 minutes starting now. Okay, now let's see how you have done that one. I was waiting for you to send me the picture of your solutions. Please send us the picture of your answer so that then we are able to can check if you have done it correctly and what mistakes you're doing so that we can correct you. Our WhatsApp number is 079 578 2908. Right, now let's look at the solution to this. Now, determine g of x into x minus 3 all squared minus 5 over x. I cannot differentiate it if I've got something like this. I cannot differentiate this, please. Right, so what I need to do is to multiply it out. So I'm going to have, and I still keep that dx because I haven't yet differentiated. So then I'm going to have, so I'm going to multiply out that. So for those who have multiplied, it should be x squared minus 6x plus 9. If you've multiplied it correctly, so it must look like that. Okay, so what you've done is, I've said x minus 3 multiply by x minus 3, then I multiply out the brackets, then from there I get x squared minus 6x plus 9, then minus 5x to the power of minus 1. So in other words, I've taken that x to the power 1 up there, so the sign will change. So now I have it nicely there, so I am now able to differentiate. So let's differentiate. When I differentiate now, I'm going to write equals 2. So I no longer write d of x, you see. So, but before I differentiate, the d of x will still remain like that, there. Okay, so now let's differentiate. 2x squared will be 2x. Remember what we do? We multiply the 2 by the coefficient of x. Then here, what are we going to have? And we subtract 1 there, so left with x to the power 1. In the next one, we do the same. We differentiate 6x. Then we're going to have 6x to the power of 0. And x to the power of 0 is 1. Then we differentiate the 9. So you see, we're differentiating each and every term there. We differentiate 9. So I'm going to get the differentiation of a constant, it's 0. Then we differentiate that one. Please remember, do not write the sign here before you multiply. So you're going to say negative 1 multiplied by negative 5. So I'm going to get a positive 5x minus 2 because I'm subtracting a 1 here. Okay. So I'll have that. So remember, I can differentiate. I differentiated each and every term. So that's what I get. Now from here I can then just clean up this. Then I can have 2x. I can have my 6. Don't need to write a 0. Then I can have plus 5x to the power minus 2. Remember, if I want to be smart, I always want to be smart in mathematics, technical maths for this matter. Then I'll have 2x minus 6 plus 5 over x squared. So I've taken, remember this is 5 over 1, so I've just taken the x to the power minus 2 down there to have this. Okay, right. Now, that is my final answer, so I don't need to write the d of x there. So I just write equal to until I get to my final answer. So that question was quite a lovely question. It's an exam type question. Okay, something different now. Now we say calculate dy over dx. Yo, I've seen people doing stuff here. They said, oh, this one we can differentiate. We can just differentiate this part here, the first one here, and just write 6x to the power of 5. We differentiate the next one, we say it's minus 1. We differentiate the one at the bottom there, we say it's 1, and we are done. And you'll get a big 0 for that. Okay, please, do not differentiate this in this way. So remember, if I've got something like this, I'm going to write on the side. If I've got 3x, x plus 2 over this one over 4, and that one maybe over 4. So how can I write this one? How can I add these two? So I can have an LCM, which is going to be 4, then 4 into 4 goes once. We'll have 3x there times 1 will be 3x. The 4 into 4 goes once. So in other words, I can have plus, then times 2 will be 2. So this thing here will be an answer to that. Now we have this answer here. We want to go back there. How do we go back there? So you see we have a 4 at the bottom. So each and every term can then be over the 4. So I'll have 3x over the 4 and 2 over the 4. So I can go back there. So same applies to this one. Before we differentiate, we must then write it in this form. So let's see. Now I can see you already have it now. Then you're having y equals to, what do I write now? X to the power of 6 all over x. See, then I'm going to say minus x over x. Then that can work out, we can work it out. We are going to have the x there, how many are left there? Will be 5. The x there and the x there, we are having a 1 over 1. So remember I haven't yet differentiated, so I'm going to have x to the power of 5 minus 1. Now I can differentiate. Okay, so I'll have y is equals to. So now let me differentiate. Dy over dx, that's what they told me to do. So the 5 times 1 will give us a 5. We subtract a 1 from the 5, we get a 4. And the differentiation of a constant is 0, so I don't need to write the 0. So the answer there will be 5x to the power of 4. And that will be our final answer. So if you've got something like this, please break it down. Then from there you can then be able to do that. Okay, now another lovely one. Now I can see some of you saying, no, how are we going to break this one down now? Because you said you must break it down if we've got a denominator and then we have that. No. Remember, I'm doing these activities, different activities, so that then when you get this type of question, then you know what to do. Okay. The last one, remember, we were breaking it down because we had a denominator of x. But here we have a denominator which is 2 terms. So breaking it down will give us a big challenge. Can you imagine if I break this down? If I break this down, I'm going to have x squared over x minus 2 minus 4 over x minus 2, and still, I need to break it down again. So we are going to spend the whole day trying to break this thing down. What is the best way to do that? What can I see? I see that we have something that can be factorized. You see, we've got x squared minus 4. That can be factorized. So if I've got a term like that, check. I can see that something there on top must factorize out so that then I can cancel out. Okay, because I know you love cancelling. So yeah, let's see how we're going to do that. So we're going to say y is equals to the factors of x squared minus 4, the difference of 2 squares. So if it's a difference of 2 squares, obviously at the bottom there will be one factor. Already I know the one factor, x minus 2. So if it's the difference of 2 squares, it means that the other one should be plus. Same terms, a plus 2 all over x minus 2. Then, because I love cancelling, that thing will cancel out. I've not yet differentiated. I'll have x plus 2. The differentiation of that is easy because I need the gradient of that line. What will be the gradient of that line? It's 1. The gradient of that line is a straight line. The gradient of that line is 1. How do I differentiate? dy over dx. And the gradient of that, 1 times 1 is 1. X to the power of 0 is 1. The differentiation of a constant 2 will be a 0. So the gradient of that line will be 1. Okay. All right. Now we have trigonometry inside these questions now in calculus. Now we have this trigonometry, cos 60. What am I going to do? How do I differentiate cos 60? We don't have an exponent now here. on the cos of 60. That 0 is not an exponent there. You cannot multiply the 0 and you multiply it by the cos there. No. Okay, now we have cos 60. What do we do with that cos 60? No problem. Get the cos of 60. Okay, you can go to your calculator and get the cos of 60. Then you get that number, which is the cos of 60. And then you are able to now we have pi. But now what are we doing? We are differentiating with respect to what? To x. So I don't worry about that pi. Because that pi now becomes a constant because I'm not going to use it for the differentiating. So if, for instance, I had dy over d pi, so I'll only worry about pi, not worry about the x. But now it's dy over dx, so I worry about the x and not the pi. Okay, so now, first of all, what should I do? I must then get the cos of 60. So if you go to your calculator and then you just type 60, cos of 60, then you get a simple value there, which is half. So in other words, this sum here, it's supposed to be y is equals to a half plus a pi minus a pi x squared. So that is what I'm having here. Okay, so before that, now I can differentiate because now I can see, oh, now I have my y value here, my x is that side. So what should I have now? The differentiation will be dy over the x. I'm differentiating with respect to x. So I'm looking at the x. So what is the differentiation of half? Half is a constant, so it will be a 0. What is the differentiation of a pi? Pi is a constant also because I'm not differentiating it. So it's a constant, so it will be plus another 0. Now, the pi has got an x squared. I must differentiate the x. So remember, if it's a constant, if I've got 2x squared, so in other words, the 2 must multiply with a 2 there. So in other words, here the pi must multiply with a 2. So I'm going to have minus 2 pi. Okay, so then I'm going to have a 2 there, so I must go multiply it by the x because I've subtracted a 1 there. So you can see that part in there. So now the zeros, I don't worry about the zeros, my answer is going to be negative 2 pi x. Nice question. Okay, so you see what we have done is we did not worry about the pi because we are not differentiating pi. We did not worry about the cos of x 60 because we can get the cos of 60 from our calculators. Okay, right. All right. Now, I want you to do this one. I'm going to give you a minute, 1 minute, to do that question. You also have a pi there, only 1 minute. I think we'll finish it in 1 minute. That one is an easier one to do. Let's do that one, 1 minute, starting now. All right, this one was quite easy. Now we're differentiating with respect to x also. Calculate dy over dx if y is equals to 4 pi x cubed over 3. So meaning that one, it's already fine, so we don't need to do a lot of stuff here. It's already fine, we just differentiate. So we're going to have y dy over dx. So I'm going to do that. So the 3 there is going to multiply with it. So I'm going to say 3 multiplied by 4 over 3. And then there's a pi there. Put it back in there. Remember? And then the x value should be a 2 there. Exponent 2 because we subtracted a 1. So the 3 there is going to multiply with the whole fraction here. Can you see? So now we have that. So the 3 and the 3 cancels out. Then we're going to have 4 pi x squared. If you don't want to do that, what can I do here? I can then say y equals to 4 pi x cubed all over 3. So what I can do is I can then say 3 multiplied by 4. So 3 times 4 will give us a 12 pi x squared all over a 3. So I've multiplied the 3 by the 4. But what is 12 divided by 3 will give us a 4 pi x squared. And remember here I must then write dy over dx. And so that then the people who are marking, your teacher who's marking, must know where you started with your derivative. Okay, we don't just start anywhere with the derivative. Once we have done derivative, we must then write dy over dx or any other notation that I've shown you before. Okay, I think the rules are quite easy. We need to be able to navigate through these rules, and we must be able to can do them. Okay, so please read your questions, practice them now. Your first principle, your rules, those two will give you nice marks in calculus, because those are the first 2 questions that you will have in calculus. Okay, now let's look at this question that is mostly, it is always there in the question paper also. In most of the question papers that I've gone through, these questions are there, the equation of the tangent. But the word, when we see the word equation, we know equation, what? The tangent. The tangent is a straight line. So in other words, the equation of a tangent is y equals to mx plus c. So in other words, we are only working with the equation of the straight line. To a curve, now we're talking about the equation of the curve, to a curve at a particular point. So in other words, we have a point that will be given to us, and then this is what we need now. What do you need for this? First of all, you need a point of contact. So if, for instance, I've got a graph like this, and I need the equation of the tangent. Let me say I draw a tangent here. I draw a tangent there. So I need a point of contact. So this is the point that I need. So if I've got that point of contact, remember a point is the x value and the y value. It's a point. Okay. What else do I need? I need the gradient. So the gradient of this line, I need m. I need the gradient. If I've got a gradient and a point, I'm able to determine the equation of the line. Okay, so we've got 2 equations here that we can use. Okay, now we've got y minus y1 equals to m into x minus x1, where I'm going to plug in the y point here, which is going to be my y value. I'm going to plug in the x point here, which is going to be my x value. So I've got x, I've got y, I plug them in. Then one thing that I need to get is the gradient of that line. So once I get the gradient, I've got the point, I'm able to get the equation of the tangent. That's all that we're going to be doing. So in other words, we need to find the gradient. So the only challenge that we're going to have here is that we're going to have the equation of curves, then you need to get the gradient. So you know, if I've got the equation of the straight line, like y it's equals to, like y it's equals to, then I need to get the equation of the line. So if I've got the equation of the line, I will be able to get if I've got a point and a gradient, I will be able to get the equation of the line. Okay, so now I just want to go back. Can I take a 1-minute break? So that then I can do that.
You are responsible for your own life.
I don't know what
No
I'm
matter how student. Nobody's going to push you to read more, to study more. You are responsible to put in the time necessary so that you can get the results that you want in your life. So today, make sure that you are putting in the work. Make sure that you are responsible in doing everything that you want to do. Because for you to achieve more, you need to put a little bit extra work to what you are doing, and keep on believing and keep on doing, and you will see the success that you want.
All right. Now, the equation of the tangent, as I said, at a point, what is the method that we're going to be using here? The first thing that we're going to use is, do you remember, as I said, that the derivative f prime x is nothing else but the gradient. Oh, now we can get the gradient. You see? So we talked about that. We said we can get a gradient of the line. So this will give us the gradient function. So once I get the derivative of a function, it is going to give me the gradient function. And with the gradient function, I know it is at the point. I can then substitute that point there. Okay, so this will give you the actual gradient if I substitute the value of x by whatever it is given. Then I can find f of k. You remember, I'll be given a point. I need a point, for instance. So I'll be given x is equals to, for instance, k. So then I need to find a y value because I need a point, a touching point. So if I'm given the x value as k, I need the y value so that I have a point. The gradient, I will have got it here. So I'm going to be able to get the equation of the tangent. So what we're doing here, we're just getting the equation of the straight line. Maybe we need to do that. Let's continue now. Now, let the equation of the tangent be that, or y equals to mx plus c. What are we going to do now? We're going to substitute the gradient, which we have got by deriving and substituting. We need to have the x value on x1. Then we need to find the y value on y1. We need to put the y value there on y1. Then the gradient, we'll have got it there. Then from there we are having the equation of the straight line. Then we write down the equation of the straight line in the form y equals to mx plus c. Still you can use that equation together when you have the points, because the gradient you'll have, your point will be x and y, then you need to find the value of c so that you are able to write it in its form, in the form y equals to mx plus c. Now let's look at the worked out example. Now here we are having y is equals to x squared plus 1. The equation of a parabola graph. We need to find the equation of the tangent of a curve at x is equals to 1. You see now they said it must demand at x equals to 1. So the x value is given. First step that you need to do. First we need to find the y value when x value is equals to 1. So I need the y value. How do I get the y value? I substitute the value of x by 1. So the value of x must be substituted by 1. Then I'm going to get a point. Now, see, I have a point. If I've got a point, what do I need? I need the gradient now, because I've got a point. Remember, to get the equation of the straight line, you just need the gradient and a point. That's all you need. So now the point, I'm sorted. Now I need to find the gradient. Now, how do I get the gradient of a curve? What do I do? Gradient, derivative. Remember, what do I do? Find the derivative, the dy over dx, using the rules of differentiation, not the first principle, the rules of differentiation, because we have done them now. Now we take this, we find the derivative, which is going to be 2x, using the rules. After getting the derivative, what did you say about the derivative? The derivative is the same as the gradient. So in other words, but we need that gradient at a point. So we cannot use 2x to get the equation of the straight line. So what do? We are given that x is equals to 1. Which means that then the gradient, our gradient, is then going to be 2 times 1. So we have 2 times 1 here. Where does the 1 comes from? It is given that it is at a point. So if, for instance, I've got this graph that is drawn, this graph would look like this. Right? So now, at a point at x equals to 1, so in other words, x equals to 1 here. So I'll have that tangent. I need the equation of that line. You see? So the equation of that line, they say it is at a point 1. But I've already got the point of there. So now I need the gradient. So how am I going to get the gradient? I'm going to substitute the value of x by 1 after deriving. So I've derived, I got 2x. I derive, I got that. I substitute. So my gradient is going to be 2. After getting the gradient, what do I need? I need the equation of the straight line. What do I need here? That is the equation that we're going to use. What is the value of y here now? It's 2. So I'm going to substitute y1 by 2. What is the value of the x1? It's going to be 1. So I'm going to substitute that by 1. And then I'm going to have my equation of the tangent, which is y is equals to 2x. So it means that that line will go through that. So it will go through the center there. Okay. And that, how do I know that I'm right? Because that gradient of that line is positive, then the equation there will be correct, because my gradient there is positive. Okay. The activity that we need to do now, let's look at this activity. Determine the equation of the tangent to that. First things first. Do you have a point? Yes, I don't have a problem. I have a point. So no need to substitute anything. What do I need now again? So the point is there. What do I need, by the way? I need the gradient now. So I need the gradient. How do I get the gradient? Is that equals to the derivative. So what should I do? I must derive that. So to derive that, I'll have dy over dx. It's equals to, easy to derive, 4x minus 5. Done. That's the derivative of that. What else do I need? I need a gradient. Remember, I need a gradient. So the gradient, it is at a point. So I use the x value because it is at this point here. So what should I do now? I need the gradient. Remember, I said derivative is gradient. So to find the gradient, I substitute that one by 1. Then I'm going to get 4 minus 5, which is negative 1. So now I have the gradient and I've got a point. So my gradient is negative 1. Now I have the gradient. What do I need? I need the equation of this line. So I'll get y minus y1 equals to m into x minus x1. So my point there, it will be x1 and y1. Just substitute. So I'll have y plus 9 equals to, what is my gradient? Negative 1. What is my x1? It's 1. So now I'm going to have y negative 9 plus 1 minus 9. Because I've already multiplied this one and that. So I'll get a negative x, negative 8, y equals to that is my equation of the tangent. So you need two things, point and what if that point was not given? Then I will first substitute the 1 into the original equation to get to my y value. Okay. All right. Now here's the one where the point is not given. But I've got the x value here. You see? Determine the equation of the tangent to this graph. It's a cubic graph. I need to find what will be the equation of the tangent at a certain point? So now, what should I do here? I need to first substitute the value of x by 2 so that I can get my y value, so that I can get a point in this form. I already have 2, but I don't know what is my y value. So I must substitute first g of 2 equals to 2 cubed minus 2 into 2 squared plus 2 minus 1. So my calculator there will give me 8 minus 8 plus 2 minus 1. So the answer there will be 1. So I'll have 1 as my answer. So my point here will be 2 and 1. So I have a point now. Now I'm settled, I've got a point. What is missing now? What is missing is my gradient. So if I've got a point, now I need a gradient. Now how do I get a gradient? Gradient is the same as this. So then I'm going to derive. So in this case is g. Alright. So I'm going to say g prime of x. Right? Then I'm going to have 3x squared minus 4x plus 1. By now you know how to differentiate now. Differentiation of the derivative of a constant, it's 0. So now I must then substitute to get the gradient. I must substitute by what? By 2. I must always substitute by x. So what is this? It's nothing else but gradient. So I'm going to have 3 into 2 squared minus 4 into 2 plus 1. Then that will give me a 12 minus an 8 plus a 1. So the answer there will be 5. So I'll have 5. So what is this 5? It's gradient. So I have a gradient of 5. What do I need? Equation of the tangent. So which in this case will be y minus, my y1 is going to be 1. My gradient is 5. Open bracket x minus my x1 is 2. Then I'll have 5x negative 10 y and then plus 1, and that gives me 5x minus 9, and that is the equation of the tangent. Can you see it's in the form y equals to mx plus c? So we can be able to write it like that, okay? So please don't forget, you must put in the formula there so that then we know that you have used the correct formula. Okay, now this one is a strange one now. Now we're having the tangent to this graph, xy equals to 4. The nice thing about this is that the point is already given. So I've got a point. What am I missing now? I need a gradient. So how do I get the gradient? Differentiate. Yeah, how do I differentiate that? So remember I've got xy. How do I differentiate xy? No problem. Write it in the form y is equals to. So meaning that I'm going to divide both sides by x. So I've got minus 4 over x. Okay, and then how am I going to differentiate this one? Remember, before I differentiate, I must write it properly. Minus 4 x to the power minus 1. Okay, so now let's differentiate. How am I going to differentiate? dy over dx. So I'm going to have negative times negative, it's positive 4. And then x to the power negative 2. Then I can write this one as 4 over x squared. Okay, why? Because I need to substitute here. So I'm going to have my gradient will be equals to 4 over. I must substitute by a negative 1. So it's negative 1 squared, which will give me 4. Now I have a point, I have a gradient. Okay, oh, yes, I've got a point here, I've got a gradient. So I'll have y equals to mx plus c. My gradient is going to be 4, and then x plus c. So I'm using the other formula now. You see? So let's see if if you use y minus y1, and if I use this one, let's see. You guys, you can use that other one. I prefer this one now. Now we substitute the value of y, it's 4. The value of x, it's negative 1. Then we have a c. So if I take this negative 4 to this side, it will be plus 4. My c will be 8. Then I can write my equation y equals to 4x plus 8. Okay, even if I use y minus y1, I still get the same answer. So you can see now you can either use that method or you can use the other one. So now at this stage I prefer that one. Okay. Alright. Now I'm going to skip that question here. I want to do something different here. Now that one will be the same. We're going to do it the same way. Now in this one, the tangent to the curve. Now I'm given that curve here. And they say it's perpendicular. Now I can see the word perpendicular. So what do I know about perpendicular lines? Now perpendicular lines, this line perpendicular to that, the gradients will multiply to give us negative 1. So in other words, if I multiply the gradient of line 1 and the gradient of line 2, I'm going to get negative 1. Now, it means that is the gradient that has been given here. They say perpendicular to that line, so the gradient is given. Now we need the x-coordinate of the point of tangency. That is where this graph here is going to touch the tangent at that particular point. So I only need the x-coordinate. I don't need the y-coordinate, I need the x-coordinate. So what should I do to get the x-coordinate to that? So I'll have. Now, first of all, I'm going to differentiate that one. So I'm going to get dy over dx, it's equals to. So I'm going to get 2x. Now, because they said, I know that this one, when I differentiate it, is gradient. Okay, so the 2x is our gradient. But now, they say this line is perpendicular to this line. I mean, the tangent of that curve is perpendicular to that. So if it's perpendicular, what will be the gradient of the perpendicular gradient of the one that has been given there? So we said line 1, gradient of line 1 times gradient of line 2 will give us negative 1. It means the gradient of line 1 will be, of the perpendicular is line 2. So I'll have negative a half multiplied by the gradient of L2 must give us a negative 1, which means L2 will be equals 2. So that answer there will be 2. But the easy way to do was to take the minus half and turn it around and change the sign of that gradient. So if I change minus 1 over 2, it will be 2 over 1. And I change the sign, which will be negative. In this case, it's negative, then it becomes positive. Okay, now I have the gradient of that. So what do? I know that this is the gradient of the tangent. So it must be equal to the gradient of the tangent. This one is also the gradient of the tangent. So it means that the gradient of the tangent to x from the derivative will be the same as the gradient of the tangent there, using the equation that has been given. So the x value will be equals to 1, because that's what they need. They need the x-coordinate of that value, so the x-coordinate will be equals to 1. Okay, so this is a very, 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 very good question here. Please practice this question. It's a nice question. Know that if it's perpendicular, you change the gradient of the one that has been given. If it's parallel, you keep the gradient as it is. You see, if it was parallel, this part here will not be 2, it will be negative 1 over 2, because they are parallel. Parallel gradients equal gradients. Perpendicular gradients, you just swap them around, change the sign of that. Okay. All right. Now, very important question again here. Determine the coordinate points of the function. This is a high-level question. You have to think a bit here. Of the function that at which the tangent is horizontal. Yes, horizontal. So the word horizontal, you know, when you say horizontal, this is horizontal. Okay? Now, how am I going to do this if I'm told that the lines, the tangent is a horizontal? First of all, remember, I don't have points, I have a function. First, I need the gradient of this. So how do I get the gradient? I'm going to differentiate. Once I get the gradient, then I'm going to equate my gradient to what? To 0. Why? It is because if I've got a curve like that, the gradient, the horizontal gradient there, can you see? Horizontal line have got, all horizontal lines have got equal, the gradients will be equals to 0. So the gradient of a horizontal line is 0. So meaning that I'm going to get the gradient, which is the derivative of minus 3x squared plus 12x. Then I'm going to do what? I'm going to equate it to 0. Why am I equating to 0? Because the gradient, the horizontal here will be equals to 0. All gradients of horizontal line will be equals to 0. The gradients of vertical lines are undefined. Alright, now I have this, so I'm going to work out my values of x. So I'm going to have negative x squared plus 4x, it's equals to 0. What did I do there? I've just divided throughout by 3. So that then I can divide that by 3, and that by 3, and that by 3, I get there. Now from here, I'm going to take negative x as a common factor. So I'm going to get x, I'm going to get negative 4, I'm going to get equals to 0. Then I solve for x. So my x value will be 0, or my x value will be 4. So I've got the two x values. Let me write this one, x is equals to 4. Now I've got my two x values, I need my y values. Because remember, I need the coordinates. So the xy. So I need the coordinates. So I'm going to get the values of y there. Substitute the value of x here into the original equation. Please, into the original equation. If I substitute 0 on my original equation, I'll get a 0. If I substitute my y values, if I substitute a 4 here, I'm going to get negative 4 there, cubed, plus 6 into negative 4 squared. Then I can work that one out. I think my answer here, that will be negative 64, and then from there plus 6 into 4 squared. So that answer there, why is it giving me a fraction? I said negative into 4 cubed. Okay, and then plus 6 open bracket into 4 squared. So the answer there is 32. So meaning that there I'm going to get a 32. So my coordinates there will be 0 and 0. My other coordinate there will be 4 and 32. So I'll have those two coordinates. Okay. The last question that I'm going to do is, so I'm going to have my last question. That question will be my last question for today. Now determine the coordinates of P at which the gradient of the curve x, y equals to x squared is 6. So what is given here? Remember, the gradient now is given. The gradient of the curve is 6. I need to find the coordinates of point P. So what am I going to do? Every time I need the gradient, I have a gradient there. I need to differentiate that so that I equate it to what the gradient that has been given. So I'm going to have the derivative, so the dy over dx of this will be 2x. So now, I know that now the gradient has been given as what? As 6. So I'm going to say, because this is gradient, the gradient there is equals to 6, but we have another gradient which is 2x. Then I'm going to get the value of x, which is going to be 3. But remember, to get the point, another value, the value of y, I need to take that and substitute it into the original equation. So I'm going to say the y equals to x squared. Then I'm going to then substitute the value of x by 3, which is going to give me 9. Now the question is determine the coordinates of P at which the gradient of that curve is 6. So the gradient is given. I need a point. So these are some high-level questions there. So I'm going to get the point P as 3 and 9. So you see, then if the question further states that find the equation of the tangent, it means that then I have to first find the gradient, and then from there get the equation of the tangent. So read the question and see what the question wants, and then you'll be able to get it. Okay, right. In conclusion, I want you to practice. You must build your math skills. You must get used to solving, the different kind of problems. Practice thousands of problems, and you'll be able to get things right and receive, helpful hints on them. Test yourself. Very important that you test yourself and drill. And also check your progress and receive helpful tips. Thanks a million, and thank you.